how cybersecurity integrates with controls engineering. Why controls engineers are modern-day industrial cybersecurity experts. How cybersecurity juxtaposes with controls engineering, and why only controls professionals are the best choices to implement cybersecurity for industrial control system, also known as ICS. We need to understand controls engineering first and then the standard architecture of an industrial plant. Hi, welcome to my channel Cyber Control. I am your cyber control guy. Please subscribe to my channel if you like my content. Don't forget to hit the bell icon to get notified about my latest video. The basis of controls engineering starts with three actions: measure, control, and adjust. Sensors like strain gauges and encoders measure the process parameters and send feedback to programmable control devices like PLCs and servo access controllers that in turn actuate the final control elements like control valves to adjust the process parameters to desired level. The beauty of controls engineering is that it transgresses operational technology assets, also known as OT assets, and touches IT assets like firewalls and remote gateway servers. It is this amalgamation of IT and OT technologies that gives this branch a very complex but unique identity. Hence, makes controls professionals very expensive individuals to employ. System integrators design their hardware and software solutions around this popular framework called Purdue model. Operationally, the model is divided into three zones. OT assets are part of the industrial zone, and IT assets are part of the enterprise zone. What separates both is this defensive and offensive layer called IDMZ, Industrial Demilitarized Zone. At the base of the industrial zone resides a unique layer of devices which protects machines and humans from harm. This is a safety layer of the ICS devices. If the machine hits a hard limit, then servos need to be shut down, or if the operator cuts the light curtain, the safety controller must stop the robot servos. Level 0 consists of sensors and actuators. These devices measure and manipulate the process directly. Hence, this level is also called process level. Level 1 is the control level. PLCs, safety controllers, and PID controllers reside at this level. The function of this level is to control the process. Now level 2 is where all the complexity begins. This is the level where supervisory decisions are made. So the hardware and software located at this level are related to supervisory control, such as batch servers, recipe management software, SCADA clients, and engineering workstations. Up to this level forms the cell area zone. A typical plant will have more than one cell area zone, like mixing, packaging, or pelletizing. Level 3 provides important site operations services like Active Directory service, DHCP service, identity service for users and assets. This site operations level hosts domain controllers, radius servers, and application servers. OPC and database servers are hosted at level 3 if the plant has a manufacturing execution system. As we move to the next level, I cannot stress enough the importance of this level in industrial cybersecurity. This creates a granulation around the industrial zone by intrusion protection sensors and intrusion detection sensors. It also authenticates users against the database of Active Directory users and computers. It allows network admins to log all incoming and outgoing connections automatically. Let's deep dive into assets situated at this level. The most important device that defines IDMZ is the firewall. There are many types of firewalls used across various industries, but the basic principle remains the same: to deploy rule-based inspection system for protocols traversing across IDMZ. Any incoming connection not aligned with the allow or deny rules will be dropped at the ingress port. Remote desktop gateway servers, VPN server, radius server, patch management server, and antivirus server are also hosted in IDMZ. At this stage, you must be thinking how all these devices communicate with each other. Well, it is done with industrial field buses by connecting those in certain topologies. The most popular and ubiquitous field bus is Industrial Ethernet, which has revolutionized the industry by achieving determinism in real-time communication to deliver industrial data packets on time and every time. Therefore, we could dream of living in the era of Industry 4.0. Level 0 and 1, including the safety layer networks, are designed with Industrial Ethernet along with other field buses. Level 2 assets are all connected with Ethernet via access switches in linear, star, or ring topology. In a medium to large industrial plant, access switches connect to distribution switches at level 3. Distribution switches collectively terminate at core switch, which marks the end of the industrial zone. Core switches delegate data flow out of the industrial zone and filter traffic that is allowed to go out to the industrial DMZ. Core switches sit at the layer 3 in OSI model, meaning they contain traffic based on the IP addresses. This is where cybersecurity comes into picture, as network segmentation is preemptive of defense in depth strategy. There is always a direct connection between firewall and core switches. For the purpose of high availability, redundancy is maintained at firewall level. Egress ports of the firewall make outgoing connections to enterprise zone core switches. Without deep diving much into the enterprise zone, let's understand what the enterprise zone is. It basically hosts the systems which help enterprise departments such as IT, finance, HR, and logistics. This is basically Office Ethernet connections. At level 4 and 5, you would be able to see MES systems, ERP systems, data centers, email and web servers, Enterprise Active Directory, and DHCP servers, identity service engines. At the edge of the enterprise sits another DMZ, protecting the enterprise from the internet. I hope you like this video. Stay tuned to watch part 2 of this ICS cybersecurity series.